Now, part 3 focuses in doing trigonometric identities. So, as we mentioned in class, when we're trying to do trigonometric identities, we're trying to get from one side and prove that we can reach the other. Okay, so one of the biggest things that we use in here is the fundamental trigonometric identity, which is sine squared plus cosine squared equals 1. And using this, we do the replacements that we need, either by sine or cosine square. So I mean cosine square of theta equals 1 minus sine square. Or we use sine square equals 1 minus cosine square. So we use either of these two that fits more the bill to try to get to the other side. So as an example, on the first one, and again, I'm going to emphasize that we always try to go from one side to the other one, and we pick the side that is more complicated. This time seems to be more complicated. So we're going to start from here. We're going to have 1 minus cosine squared over 1 plus sine of theta. Clearly here the issue is that we need to get rid of whatever we have with this 1 plus sine of theta down here. And to do that, we probably want to factor something out and cancel. So we're going to transform this cosine in terms of 1 minus sine squared. And then here we're going to use a difference of the squares. So if you remember, the difference of the squares is a squared minus b squared equals a minus b, a plus b. And so here this will be 1 minus sine, 1 plus sine. Since 1 is a square as well, 1 squared is just 1. So now that we have that, notice that we have 1 plus sine of theta times 1 plus sine of theta over 1 plus sine of theta. So we can kind of cancel this out, this whole term. And now we're going to get 1 minus sine of theta. At this point, we can see that we're going to reach what we want, because this 1 is going to cancel out with this 1 when we break apart the parentheses. The minus distributes, so this is sine of theta, 1 minus 1 sine of theta. The 1 and the 1 cancel out, and this is just sine of theta. So notice we start from one side and we reach to the other side. We do some transformations, we do some algebra in the middle, but that's what we need to do to go from one side to the other. Now let's go to identity 2. We have sine squared minus cosine squared divided by sine to the 4 minus cosine to the 4 equals 1. Now in here, again, we want to get to 1, but we want to make sure that we start from one side to reach to the other. Let me erase this here. So we have the sine squared minus cosine squared of theta over sine to the 4 minus cosine to the 4. You might be inclined to do difference of the squares on the top and the bottom, but if you think about it, you only need to do difference of the squares on the bottom here, because this is sine squared of theta minus cosine squared of theta, and then below you can factor this as sine square minus cosine square. So now you see the difference of a square in there. And you see that we're going to get factors that have sine square as a and b for our identity. And so this is sine square minus cosine square divided by sine square minus cosine square times sine square plus cosine square. And so now you can see why this is 1. This gets canceled with this, and we get only left 1 over sine square plus cosine square. Oh, but this is 1 as well because this is the main identity. So this is 1 over 1, and we get just 1. So again, we come from one side and reach the other side. Now let's go to identity number 3, or identity C. Here we have 1 over 1 minus sine square equals to sine square over cosine square plus 1. Here's a kind of a little bit difficult to kind of guess what I should do. I'm more prone to actually go ahead and start with this side. I think it's going to be easier from this side, since cosine square is clearly 1 minus sine square. But notice that if I start with sine square over cosine square plus 1, I can just see that 1 as cosine square over cosine square. Right? 1 is cosine square over cosine square. And so now, because they have the same denominator, I can put this together in a fraction. And this is just sine square plus cosine square over cosine square. And now the top is 1. And the bottom is cosine square of theta. But I can see cosine square of theta as 1 minus sine square of theta. So again, we went from this side and reached to this side. Can I do it backwards? Sure. You can start from here and just go in this direction. As you can see, you can just go now in this direction. And this is also a way to get to the same point. So you can go in either of the directions to reach the other side. Okay. Now let's go to identity D. In identity D, we have cubes and squares, and it should be equals to a sine. So this side probably can be factored out and simplified a lot. And because everything is in terms of signs, I just simply gonna keep those signs around. And my intuition tells me that I should just transform this cosine square. So this is sine cube of theta plus, and this is 1 minus sine square of theta, sine of theta. You might be saying, but well, what do you mean your intuition? That's probably because you have practice and everything, and that is true, certainly. But the key is when you're reaching to the other side, you only have sine of theta. You don't have cosines. So that's what it tells me. I should probably change this cosine square into 1 minus sine square and see what it leads. And for sure, that's actually going to be the solution. Notice that this is sine cube of theta. And if I multiply this here and distribute, this is sine of theta minus, and then sine squared by sine of theta is sine cube. So I get sine cube of theta minus sine cube. I get to cancel those out. And this is just going to be sine of theta. Super simple. Okay, but you gotta think about we're going from one side to the other, and I gotta make a small transformation. Now, last but not least, sometimes in identities you can actually play around and use some of the information that you have from other identities. So for example here, we get cosine of pi plus theta equals minus cosine of theta. So the notion is the same. I should start from one side, cosine of pi plus theta. But what I'm going to do here is I'm going to use the double angle identities that we've been using on part 1 and part 2. And so this is going to be the cosine of the double angle. So cosine of pi times cosine of theta. And then minus, because that's what the formula says, sine of pi, sine of theta. Now notice sine of pi is 0. So this goes away. And this whole thing becomes a 0. And cosine of pi is minus 1. And so, I'm left with minus 1 cosine of theta. And this is minus cosine of theta. So as you can see, a very simple identity. So we reached to the end of the reviews of chapter 9 and 10.